Hey guys, and welcome to another virtual lesson where we're going to do some demos, this time involving redox chemistry. So redox chemistry is just basically electrochemistry. It's how things create electricity and how electrons get transferred. So I'm going to do 3 demos for us this week. First demo I'm going to take a regular battery and I'm just going to put it in a cup of salt water. Now, when I do this, I'm going to use a spoon just so I don't have to stick my hands directly in the water. But when I do this, you guys should see that there are some bubbles being created. There's some kind of sort of fizz coming out of one terminal of the battery. So I'm going to let that go for a little bit. And what's happening here is when that battery goes underneath the salt water, we're what's called electrolyzing or splitting up water molecules. We're creating hydrogen and oxygen gas. Now, the most important part of this is the reason we create this is because of something called reduction and oxidation reactions. Again, we're talking about redox reactions. Read in the redox means reduction, and the ox in redox reactions means oxidation. So the water is being split up into hydrogen and oxygen, and the reason it does that is because that positive on the water, or on the hydrogen, it's gaining electrons to become a zero charge, and the negative on the oxygen, it's losing electrons, it's oxidizing, losing electrons to become more positive. So I'm going to take the battery out of the water here. But again, I think a super interesting thing that happens here is a reduction and oxidation reaction doesn't just happen with the water. You can also see, once I dry the battery off a little bit, you can also see on the battery, one side has turned green. It's the positive side that's turned green. And the reason that happens is the same exact reason that the Statue of Liberty turns green. The Statue of Liberty is made up of copper. The terminal on this battery is also made of copper. When copper oxidizes, right, when it loses electrons, it turns green. And so that's why the end of this battery, and that's why the Statue of Liberty is green. Because the copper has oxidized, it's lost electrons to become copper oxide and turn it green. The second demo I'm going to do should hopefully be one that we're all familiar with. Sparklers work because there's a redox reaction happening in the sparkler. What happens is magnesium combines with oxygen. It's oxidizing with the oxygen in the air to produce magnesium oxide. So just like the copper on our battery, this metal is being oxidized and it's combining with oxygen. Just like in our other reaction, we have something that is either losing or gaining electrons. So actually, this MgO, that should be a +2. So this goes from a 0 to a +2 in the magnesium. The oxygen goes from a 0 to a -2. So again, what happens here is we have something that's gaining electrons. The oxygen is becoming more negative. And our magnesium is losing electrons. It's becoming oxidized. It's becoming more positive. And I think we all know how a sparkler works. But for sake of clarity and for sake of doing the demo, what you have, this is ever going to light. Oh. That's a shame. It's too windy here, so I can't light the sparkler. But basically, when this redox reaction happens, you have all of these sparks being created. That normally would have been an issue, but there's another demo that I'm going to do at the end of this video. You guys will still see sparks, don't worry. The last demo I'm going to do, and probably the most exciting that you're ever going to see, because it's my favorite demo, is one where I have steel wool and I just wrap a copper wire around it. So, what happens in this demo is steel wool is actually mostly made of iron. Iron is Fe. And so just like the other metals in our other demos, the iron will lose electrons, it'll become more positive, it'll be oxidized, and our oxygen around it in the air is going to gain electrons, become more negative, so that's going to be reduced. What happens in this reaction is that iron, that steel wool, combines with the oxygen in the air around it, and I'm going to swing it around from this copper wire, and we're going to see what happens. I have to wait until nighttime so you guys can really see exactly what's going to happen in this demo.